All right, so let's start with the announcement reminders before we do a recap from last time. Notes template, you know how to find them. And next Friday, not this Friday, the TA and myself will be there to help you on lab number 1. Let's now take a quick look on the calendar, right? It's really important for you to know where we are. If you go to the semester calendar, we are now here on the 26th. Next week, Monday, your lab number 1 will be due, and then I'm going to release lab number 2. Okay, please take a look. On the lab 1, you want to get started as soon as you can. 1 week already passed. If you got any question about lab number 1, you can drop by my office hour, or the TAs and myself will be in the lab session on the coming Friday. So this coming Friday. So you can also ask questions to us as well. And so this Friday, just schedule lab Q&A on your lab number 1 or any other course material. If you see me there, just ask me about anything. All right, so next Friday, June 6th, will be your programming test number 1. I'm going to release a guide, very similar to the guide you received about programming test 0, hopefully by Thursday class, so you will know exactly what's going to be covered. I will also release a practice test for you guys as well. That one may have to come slightly later, but Monday the latest, you're going to receive the practice test 1. So you still got a few days, 4 or 5 days to actually practice that. I'll do that as well. And tentatively, there will be a review session, optional, but I will encourage you guys to come if you need any additional help on the practice test. So next Wednesday, tentatively, will be the only time I can actually make it. I'm going to send out a very brief survey on E-class just to see on Wednesday which time might be better for you. I'll give you some options. It's going to be in person, not over Zoom, because I will be on campus on that day. So I'll prefer in person. So come, and then I'm sure it's going to be worth your time if you do come. All right, I will reach out to you guys about the details for that particular review session. Next Wednesday, June 4th. Okay, and then, so the guide and the practice test, and your priority now should be to complete lab number 1. Lab number 1 is definitely going to be covered in programming test 1. That one's for sure. There might be some additional stuff which I'll confirm in the guide later. And you definitely also want to review the classes and object slides. It's always there, the basics, right? It's just the foundational building block you cannot get away from. Guys, any questions? Yeah. You mean for programming test 1, right? Yeah, I'll confirm the exact coverage maybe on writing, maybe before Thursday's class. You'll see that exactly. But definitely lab 1, that's for sure. There might be some additional stuff which I'll confirm in writing.
So lab 1 plus something else?
Plus something else, yes. Lab 1 for sure, yes. Okay. All right, guys, any other questions about the course in general? Okay, let's now do a recap. So last time we finished the last bit about the review on OOP. Specifically, we did static variables. And you can see this example here. The counter that's as part of the programming pattern we have studied in lab 0. Rather than being non-static, we actually introduce static. And things might go wrong at the runtime. So this will be the kind of example you want to get used to. So everything compiles, but just at the runtime, it will not work as expected. That's something you want to get used to. Okay? You want to be able to explain exactly what went wrong and also to really see how you can fix them. That's actually very important. And we spoke about another common error, which is about how you can refer to non-static variable in a static method. Right? We spoke about the reasoning behind why it would be an error. So you can take a look as well. And we spoke about 2 possible fixes, right? Both will work programmatically, but one actually will make more reality sense than the other. You can review, also see which one will make more sense. And we trace this program here just about when you have a method that might return some reference type value. In that case, how things are going to work internally. Internally, you may also got some reference type variable as well. So there will be multiple objects that will be created throughout the tracing. So that's something you want to get very clear about as well. Right? You can refer to the tracing detail over here. Right? We have been using this kind of diagram. I think that's pretty effective for us to trace the program. And we talk about the use of this rather than just to get rid of the, not just for getting through the variable shadowing, but we also see how we can use this keyword in a more advanced context. For example, on the right-hand side in the variable assignments. And you can go through the exact reasoning I kind of went through. We started with some example here, and then to work out which one is the context objects and which one is the arguments. And then we work out what should be written in general as these two lines using this and also the parameter, right? You want to generalize the context object into this. You want to generalize the arguments into the parameter. So that will be the two principles you want to follow. And we also spoke briefly about how to use the ampersand. Just remember that means conjunction and also we got a vertical bar for or. So this is also the stuff you learned from the first year. And I gave you guys some exercise over here, right here, right? So what if we want to organize the conditions slightly differently? So you can try to exercise, try it out on Eclipse, use the debugger, use the breakpoint to find out the answer as well, okay? I'll leave that exercise to you. And so that was the last concept we spoke about, right? So that's gonna involve the new lecture. I already put the slides on the lecture site. We're going to talk about exceptions for today and also Thursday. Hopefully I can finish the majority of that. There might be some leftover example maybe for next Tuesday, but the principle will be covered today. I'm also going to use the Eclipse to develop some example from scratch for you to get some feel about where to program exception. Exception, if you're learning that for the first time, it could be very tricky because it's really about how you can trace the code properly, especially method call. So I'll start a little bit more gently and also give you some high-level example to summarize the principles, and then we'll do some concrete example on Eclipse, right? So that'll be the plan. We'll see how far we can go to. But for today and also Thursday, exceptions. Before I go back there to review about these two concepts about caller versus callee, let's start with some introductory slides, and then we'll go from there, okay? Okay, we're starting from this new slide here, exceptions, right? Okay. By the way, lab number 1, you don't really need to use any exception just yet. You'll be starting from lab number 2, you're going to need exceptions, okay? So in this exception lecture, we're going to learn about caller versus callee. We're going to review that again. There's a little exercise I can assign to you guys to give it a try, and I can go over the solution very quickly with you. Error handling. So this bullet point here, I'll talk about it maybe at the end of the lecture. Without using exception, the best you can do is to say system.out.println line and then some error. So the error messages will be printed to the console. This might work in some very small scale, but in the larger scale software, this solution here using console messages will not be acceptable at all. Because only using exception, you will somehow force either the caller or callee to somehow handle the error from one side or the other. It can be somehow enforced using the compilation messages. That's something I'll show to you guys a little bit later. But for now, just got to remember, console messages will be some alternative, but it's simply not acceptable for scalable software, just not. And to really learn about exceptions, the most important principle we're going to follow is called catch or specify requirements. If you don't really satisfy this requirement here, your code containing exceptions will not even compile. So the catch or specify requirement is more like a compilation rule you have to follow. That's also something I'm going to introduce today, give you some example, and then also try it out on Eclipse as well together with you. Okay? Catch or specify requirements. That's the number 1 principle to review about exceptions. And I'll do some example together with you, just with the same kind of structure there, but we're going to see where to handle the exception at a different level of the caller. We'll get to this around halfway through today. And then we'll see error handling via exception, the same example, also give you some generalization. And then there will just be more examples there. There will be some kind of interesting example we can use on Java API library I'll show to you. Okay, that'll come maybe most likely Thursday. But for today, I want to review this part here. And then I want to cover this example here and summarize about catch or specify requirements. I got to make sure I can repeat maybe as many times as I can when I cover the exception. That's really the most important thing to understand about exceptions. All right, so we'll talk about caller versus callee. And that's the example we started with on last Thursday, right? Let's now review very quickly. So caller is really a method. Callee is just another method. How do you define caller versus callee? Caller is simply a method that calls another method. And callee is simply a method that's being called by another method, right? It's more about being passive or active. Let's say this example here, okay? You can think about this class over here. I got C1 and M1. This is the context where a method called C.M2 is being made. And if you look at that, the context where the method call is being made is called a caller. Okay? So at class C1, method M1, we try to make a method call. The method call is CO.M2. And the O here is a reference variable being the context objects. That one was declared of type C2. So we say that C2, M2 is the callee. That's the method that's being called in this context over here. So we say caller here and callee over here. That's what we had from last Thursday. You want to be very familiar with caller versus callee because we're going to talk about something called a stack of method call today when we trace the execution at runtime. So you really have to be clear about where the caller is and where the callee might be. Okay? So let's do this little exercise together just to get a little bit more feel. So we're asking, can a method being a caller and callee simultaneously? The answer is yes, and that happens just very often. All right? Let's just take one example, and then the other one, you can also try it out yourself. Okay? Let's say, first of all, the answer is yes, definitely possible. Okay? One example would be, let's say here we already got one caller over here, C1 and 1. Is it possible that we make C1 and 1 also a callee at the same time? Yes, we can, because we can simply say, let's just make another caller that is going to call this method M1. So this C1 and 1 will just become callee because it's being called. Okay? So alternative number 1. Let's now make C1.M1. And guys, by the way, as I tried to emphasize last time, when I say C1.M1, I'm not really indicating M1 is a static method. I'm not. Right? I'm just using the notation here. Because every time, if you want to refer to a method as a caller or callee, you better also mention which class it comes from. Because between classes, method might share the same name. So that's why I want to disambiguate that. Okay? So C1M1 currently is a caller. Can I also make it a callee? Yes, I can. I'll show it to you. Also a callee. Basically, I want to create a context where I can simply call this method. Now I got choices. Either I can try to call C1 M1 in the same class, or maybe I can have another class and call this C1 M1. I can have either way. Right? I'll show you both. It could be that maybe I got class C1, just the same class, right? And also I got ... Let's say I already got this part here, M1, declare, right? So what I can get is I can say void, let's say M2. Let's say somehow this new method M2 depends on M1, let's say. In this way, I can simply say this dot M1. So by writing this line over here, I'm also making M1 being the method that's being called. Right? And what's this? This should be the same class, C1. All right? So this context over here also makes C1.M1 a callee. C1.M1 also a callee. So you can see in this context over here where this method call is made, C1.M1 is a caller. But now in this context over here, C1.M1 is a callee, right? So you can see the same thing, but it can be caller or callee, depending on which context you're talking about. Another one could be, for example, let's say we got, let's say class C3, let's say we got another class. And then we just got M, let's say. Void. And first of all, we got to create C1 objects, right? So we can say C1, and then we say object obj. New C1. After that, I can say obj dot m1, which is declared right here. So in this different context over here, C1.m1 is also a callee. It's also being called. It's just that it's using a context objects, right? So this one here, where C1.m1 is also a callee. I'm just showing to you two possibilities. And in both possibilities, C1.m1 is also a callee, right? Any questions about this? These two are really the same. It's just that when you are trying to call this method here M1, you can either try to call M1 in the same class, or you can call M1 in a different class. That's the difference. Which one do you really need? In reality, it depends on your need. So both can make C1 and M1 callee. Question? Yeah.
So for the second case, does it still prove that C1 M1 is the caller and callee?
No. So here, if you look at C3 over here, right? Yeah. So now, in this case, as far as this method call is concerned, the caller is actually C3.m. But this one here, C1.m1 is a callee. But C1.m1, in this particular context, is actually the caller. So think about every method call is going to trigger some caller-callee relationship. Okay? Guys, let me say that again, but you can catch a recording later. As far as this method call is concerned, C1.m1 is a caller. Okay? As far as this method call is concerned, C1.m1 is a callee, whereas C3.m, where the method call is being made, is a caller. Okay? So every method call is going to give you some caller and callee. Yeah? Sorry? I mean the left-hand side? Yeah. Similar. So as far as this method call is concerned, the caller is C1.m2. This is where we're making the method call, right? And the callee is actually C1.m1. That's the method we're calling. All right? So every method call has its caller and callee. Right?
So I have a question about the first one. So if you were to do that, would that make it so that if you called if you do like C1 dot like M1, would that make it like run infinitely because it would call M1 if we call M2?
Right. You're more talking about if a method calls itself, right? If a method calls itself, it's something called a recursive call, but I wouldn't really go there just yet. You're right. Whenever you're trying to make a method call itself, you might run into some infinite recursion, but that's not something we're going to worry about until the very last few lectures in the semester. Yeah. But for now, we're just trying to say every method call is going to suggest certain caller and callee. You guys should know how to identify them. That's what we are focusing on. Yeah. Question?
Just when you say like simultaneously, you just mean like within like the same package or something?
Let's say within the same projects. How about that? Okay. Yeah. Of course, the way to disambiguate would be you may say package name, class name, and method name. But within the same package is fine too. Yeah. All right, guys. So what you should really try is you can see here, this guy here is a callee. Can you make it a caller in a different context? So that will be the exercise for you. Exercise. Make C2.m2 a caller. All right, so that would be your little challenge, but that should be quite easy. All right, I'll let you think about it. All right, caller versus callee, right? You got to be sure you really understand that. And then the next one, I want to talk about a chain of method call. Whenever you got method call, it might be a method call calls another method, which calls another method. So you get a chain. And we ought to know how to trace the chain of method call. And that one there is going to be very useful for understanding exceptions at the runtime. Okay, let's now build some foundation here. Okay, right here. All right, let's say we got 3 different contexts over here. Let's say we got method M1. Let's not worry about where they are. They might be different classes. Could be C1, C2, C3. Doesn't matter. But for now, let's say somehow this method M1 somehow calls M2. And M2 over here somehow calls M3. M3 over here doesn't call anything. Let's say that's a setup. And we want to somehow trace it, to see what's going to happen at the runtime. And then we're going to annotate each line with a precise sequence number to know what's the order of executing the code. Let's work it out. Right? It's also going to help when we actually get to the more detailed tracing. Whenever you want to trace some code, you want to know what's the entry point of execution. Like what's the starting point? Usually in Java, the starting point could be either your JUnit test class, maybe as test case number 1, or it could be, let's say if you're doing console application, the entry point of execution will be the main method, right? It depends what kind of application you're building. But for now, let's say we assume M1 is going to be entry point of execution. So let's start from that. So M1 here is going to be our starting point of tracing. So I call that the entry point of execution. So we're going to start our execution from there until termination. Okay? So I'll start from there, and then I'm going to label the line number one by one. And here, I'll just, whenever you say horizontal line, I simply mean there's no further method call. So line number 1, line number 2, 3, 4, and 5, different lines in the method, right? And somehow line number 2 for M1 makes a method call, in which case we're going to trace further, like a step into M2, all right? Let's now try to trace it. In order to trace the method call, standard way to do it is by using something called a call stack. For this course, we don't really have to go very deep into what a stack is. That's something you guys will learn in 2101, the data structure course. But I think I'll just give you just what you need to know about a stack. I will go over just by example to see how we can manipulate a stack. Basically, think about a stack is like a container. You can add something into it, which we call push. You can also remove something out of it, which we call pop. Right? I'm going to show you exactly how they work in a very intuitive way. It's not difficult. The call stack is going to be very useful for tracing the method call. I'm going to show you how to do that. Later on, once we get a recursion at the end of the semester, you also need call stack to trace the recursive call. So you get 2 occasions to use it in this course. All right? So the way to really draw a call stack is you're going to draw something like this, as opposed to like an array, which will go from left to right. So there's a reason for that, which I'll explain a little bit later. Okay? Whenever you want to trace using a call stack, draw something like this, which means things are going to be added in this kind of order. Number 1, number 2, number 3, and number 4. When I want to remove something out of a stack, number 1, number 2, number 3, and number 4. So the order in which you add things into the stack will be reversed when you try to remove things out of stack. That's something we'll observe. It's something called last in, first out. Okay, call stack. The most important thing is called last in, first out. Or LIFO. It's also a very standard acronym for what a stack is. But let's see exactly how to do it. So what we do is we're going to put in method call into the stack as soon as we try to start executing that particular method. What we start with is we got M1 right here. So M1 is going to be, we said, added or pushed onto the stack, M1. So whenever stack operation, so you got stack operation. So either you can say add, or the more standard way is to say push. Or you can say remove something from the stack, but people usually say pop. In this course, I'm not picky. You can say add something to the stack or remove something from the stack if that's more intuitive. But if you want to say push and pop, that's also fine. Okay? I'll just say add and remove. I'll try to stick to it. This will be the entry point of execution. I'm going to add M1 into stack. If a method is in the stack, that means we're still actively executing the method. As soon as the method execution is finished or terminated, we're going to remove it from the stack. But not yet for M1, not yet. Okay? And then we're going to step into M1. Line number 1 is going to be here. And then we're going to get line number 2. Line number 2 is going to execute another method, M2. At this point, since we're going to start executing M2, before M2 terminates, M1 is not going to continue. That's a very important concept over here. So we are saying the following. Okay, so here I'm going to highlight here. When M2 is being executed, M1's execution is suspended. And the way to visualize this is, since we're going to execute M2, so we're going to we're going to add M2 into the stack, M2. So what does that mean? That means currently we're actively executing M1 and M2. Somehow M1 starts its execution earlier than M2 because somehow M1 is lower in the stack than M2. Right? I'm just trying to show you what visually it really means. Because the order where method calls appear in the stack also matters. All right, so let's now step into M2. Okay? If you step into M2, so this is M2, right here. So M2 has been already added to the stack. So now we're going to annotate each line in M2. So this will be number 3 and number 4. So the labels I'm creating now, 1, 2, 3, 4, simply represent the order of execution. You can see we don't really continue from M2 to here and to here right away. We have to somehow wait until M2 is finished, right? Okay, 1, 2, 3, 4, and then we got another method call right here, which is M3. Right, so this will be number 5. Okay. And you can think about this one, I'm just going to say that verbally. When M3 starts executing, the execution of M2 is going to be suspended. All right? And the way to put it is we're going to add M3 into the stack. Let's do that. So we got M3 right here. At the moment, all the 3 methods are being actively executed, even though M1 and M2 have been suspended just for now. They will be resumed for their execution when their earlier method is being done. All right. Let's now go a little bit further. So now we're going to step into M3. And this part here is pretty straightforward because here you can see we got a line here, 6, 7, 8, 9, and 10. There is no further method call until this point over here, after this point. At this point, M3 terminates or finishes its execution. And it will be the time to really remove it from the stack when it's terminated. So this one here will be M3 finishes its execution. And in general, if there's any further method call, for example, from here, then you will have to actually push, I keep saying push and pop, right? So let's say if there's another method call right here, then you have to add that method call into the stack and suspend M3 accordingly, right? So the pattern might just go on, right? But I'm just showing to you like a chain of method call M1, M2, M3. Before I try to remove anything from the stack, let's review our concept about caller-callee. How many caller-callee relationship do we have right here? If you think about it, how many? To really see how many caller-callee relationship, you just have to count how many method calls do we have. We got method call number 1, we got method call number 2, right? So these are the 2. All right? So what you got to do is, let's now annotate very quickly. Think about this one here. As far as this one is concerned, we know that the caller is M1, and the callee is M2. And if you look at this one here, the caller is M2, and the callee is M3. Right? So these are the 2 method calls we have, right? Caller and callee. And apparently, you can see that for the same method here, M3. you can see M3, the same method can both be the callee. Oh, beg your pardon, M2. That's what I meant to say. For the same method M2, it can both be the callee or it could be the caller simultaneously, right, in different contexts. So this is just another example to show to you. Okay. All right, so let's now try to finish the execution. So after N3 has done its execution, we're going to remove it. So you're going to remove N3 from the stack. What does that mean? That means you're going to put M2 out of the suspension. So M2 should really resume back to the point where it got suspended. M2 was suspended when we tried to make this method call. But since that method call has been removed from the stack, that means it is done. So now we should really resume from this point here. All right? So after 10, it should be 11. 11 here, and then 12 over here. Okay, for that one, let me make a very quick notes for you. Okay, so think about what we're having here is right like this. 11 here. After N3's execution terminates, M2's suspension is cancelled. And is resumed at this point. And resume right here. All right. So that's why we got 11 and 12. And after this, we know that M2 is done. What should we do? Remove it from the stack. All right. So if you try to remove it from the stack, we only got one method that's in the stack, M1. We're going to remove it from the stack, but not yet. At this point, M1 should be put out of suspension. It should be resumed. Where should we resume, though? Not from line number 1, from where it got suspended. M1 was suspended before, right from this method call, M2. But M2 is already removed, right? So now we should really resume from this point here, right? So now for that one, we're going to have 13, 14, and 15. And at this point here, we actually have done with the execution of M1, so we're going to remove it from the stack. So now the stack is empty. What does that mean? No method is now being suspended. Every method has been done. Okay? So that's the complete tracing for a chain of method call. This will be something you have to know how to do it on a piece of sketch paper whenever you want to trace anything to do with the exception or maybe later on for recursion in general. And a final recap. This will be the starting point for the method call chain. And you want to really see the number here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then resume 11, 12, and then resume 13, 14, 15. Right? Let's now make some very quick generalization. Well, just make some more observation. Okay. Let me put a stack over here. So that was the stack. We started adding M1, and then suspending M1, we got M2. Suspending M2, and then we got M3, right? So what you really want to observe is M1 over here was called the earliest. On the other hand, N3 over here was called the latest, but it finishes the earliest, right? Finishes the earliest. All right? And then you want to think about this order over here, M1 followed by M2 followed by N3. That would be, we'll call it chronological order of making the method call. M1 followed by M2 followed by M3. So M1 followed by M2 followed by M3. So this is the so-called chronological order. Chronological order of method call. All right. And then if you try the other way around over here, let's say if you try M3 followed by M2 followed by M1, that's exactly the reverse. So that order will be the order in which method terminates, which is the reverse. Okay? So this one here is the order of methods termination. Just notice that these two orders are exactly the reverse of each other. That's the nature of what a stack is. All right. Okay, one more thing on my notes. Let me draw the stack one more time. So if you look at the stack over here, and we say that this element here that you added the first, it is called the bottom of the stack. And you may have as many method calls as you like, depending on how long or how deep the method call chain is. The top over here is called the top of the stack right here. There will be the method that's added the last, right? So this one here is called the top of the stack. Okay, we say this is the bottom, and keep adding until you get to the top. And let's not worry about capacity of the stack. That's not a concern for this course. So the method call chain you have can be as long as you might need. Okay. Question?
For this particular, in this particular example,
Mm-hmm.
the methods, they don't have parameters. They're different.
Yeah, we don't have any parameter or argument for the method call. Just make it simple.
Oh,
Yeah.
So if we need how we draw with the stack, does it first call the parameters first? How does it work in the stack?
So I think for now, let's be simple, right? We don't need to worry about if. In general, of course, the parameter, when you make a method call here, the argument itself may be another method call. It could be, but let's not go to that complicated. Let's now focus on the foundation. We're just saying that the parameter here, even if I put parameter over here, just maybe some integer value, reference variable, that's okay. As long as it does not involve any further method call, things will remain to be simple. Right? So we start with M1, and then we go to M2, and we branch out to M3, and etc. I think that'll be good enough to understand what we're going to say for the exceptions. Yeah. All right, guys, any other questions? All right, yeah.
Sorry, could you explain the caller and the callee again?
Sure, absolutely. So whenever you got any, okay, thinking this way, each caller-callee relationship really corresponds to a particular method call. So when I ask you the question about how many caller-callee relationship do we have, you just count how many method calls you have. You got method call number 1, you got method call number 2. The method being called here is a callee, which is M2. The method being called here is M3, that's also the callee. And the context where the method call is being made is the caller. So here M2 is being called by M1. So M1 is a caller. On the other hand, M3 here is being called inside M2. That's a context. So M2 is a caller. Okay, no problem. All right. All right, so if you're okay, I'll try to go very slowly, right? Because I know this is kind of difficult, kind of tricky for the first time you're listening to this. All right, so the next one will be, okay. I'm going to talk about, given this kind of idea here about call chain and also caller-callee, now I'm actually somehow going to show to you about how exceptions will work conceptually, and then we'll take a break afterwards, and then we're going to do on Eclipse. Okay. Guys, the next page is going to be a bit ugly, but just sustain, all right? but I'll guide you through. Let's say the following, okay? And this is actually a call chain somehow. Can you actually see a stack somehow? Okay, let's now do the following first of all. Okay, let me just tell you what I'm trying to do here. Let's say the main method here, which is the bottom of the stack, this is the entry point of execution. That's why it's at the bottom. The main method somehow calls one method here. And this method in turn calls another method. And this method here calls another method. And this is the top of the stack. That's a call chain. All right? To make it a little bit similar to what we had, why don't I draw a stack right away? So this is the stack. All right? That's a stack. Right? The bottom all the way to the top. And number one, I want you to see this. What about the order of the method call? Think about the arrow over here, right here. Oh, by the way, you actually do have this diagram here on the lecture side. I want to show it to you very quickly. So you can feel free to also print it out or load it to your tablet computer and practice annotating yourself too. So if you go to the lecture site, you will see that under diagrams for this week, you will see call stack here in general. So that's exactly the one I'm trying to annotate, right? Okay. So we do have a call stack, and then these arrow over here are just about the order of calling the method. Okay. So that's so we do have the order here, in this order. Okay. So this one here is the order of method calls. And let's now focus a little bit more on this. From this particular call chain, can you somehow identify the caller callee? Right? So let's now, for our reference, you can see this is the main method, right? Right? There's a main method, and main method calls another method. Let's call it M1. Okay, just call it M1. M1 in turn calls another method, let's call it M2. M2 in turn calls another method here called M3. Okay? Let's be very thorough over here. As far as this particular method call is concerned, where main calls M1, who is the caller? Main. Okay, good. You guys know, yeah, it's pretty simple. Yeah, I should just answer myself, right? I shouldn't bother you. Okay? So as far as this one is concerned, the caller is really the main. And the callee is really N1. Okay? Let's do something similar here. As far as this particular method call is concerned, you can see that the caller will be N1. Agree? And the callee is actually M2. Right? You can see given M1 can be callee or caller, depending on which method call you're talking about, right? We're just emphasizing the point, right? For completeness, let's do the final one. As far as this method call is concerned, right here, let's say this one over here, we got the caller being M2 and the callee being M3. So we got three caller-callee relationships simply because we got 1, 2, and 3 method calls, right? Logical. Now, something might go wrong at the runtime. Okay? So that's why we are learning about exception, just conceptually. You can think about exception is going to be thrown or is going to happen whenever there's some error about the input that's being passed to the method actually goes wrong. For example, if you actually want to calculate the area of a circle, if you somehow pass like a negative value as an input, it's like an error because you don't have any circle with negative radius, right? Things like that. So this is where something goes wrong. So we say this method where error occur and some exception object is going to be thrown. I'll talk more about exception object a little bit later once we see the Java code. Okay? But you want to understand right here, M3, this is currently the top of the stack. Something goes wrong. So this is where we are not going to make any further method call because something goes wrong. We gotta pause. We gotta stop right here to handle the error. All right. So M3 is where the exception is originated. And exception is originated. So somehow we're going to gradually think about different methods from the top down to the bottom to think about how things might occur. So I want to guide you through the principle first, and then I'm going to show you on Eclipse like how things might work differently. Okay? Let's say this. So there is a principle there called catch or specify principle. I'll write it down here. It's called catch or specify principle. So that's the principle we're going to go over in detail. I also try to exemplify the principle in different locations in this diagram here. But let's go one by one. So this means whenever you got some method call that might potentially give you some error, you got two options. Either you can catch or you can specify. Okay, that's intuitively what it is trying to say. But let's say exactly. Also, one thing to mention, whenever you see catch also means we're going to handle the error. And when you see specify, that means you don't really want to handle the error. Instead, you want to propagate the error to your caller. Okay, I'll show you in one moment. Rather than handling the error, you're going to propagate the error. Either you take the responsibility to handle the error, or you push the responsibility to somebody else. Either way. So catch or specify requirements. And whenever you're in this kind of situation, you got to decide which way you want to go. Okay? Let's start from principle here. So 0 will be parse 0. Okay? 0. Where the exception occurs or is thrown, we simply specify. We don't really handle the error right away. We don't. Let's say this M3 is where the error actually occurs. We don't really try to handle that right away. We only specify it. Okay? So that's principle parse 0. Where an exception is thrown. If thrown simply means occur. Just specify it. All right, so that means this particular one here, M3, this is how M3 is going to respond. Okay? So this is M3, and we simply say M3 simply throws and specifies the exception. Now, let's go over this. And then after the break, I'll show you exactly how things can be understood following these principles in Eclipse. But just go over them first. So I would suggest after today, it wouldn't make much sense at this point because I'm just going over the principle. You really want to go over the example after the break together with this principle here on the page before Thursday. Okay? Okay, just specify it. Okay? This is parse 0 I just mentioned. Okay? The method where the exception is originated, just specify it, which will make sure the exception is somehow propagated into its caller. Remember, M2 calls M3, right? Whenever you propagate the exception from your side, you basically propagate it into your caller. Okay? So this will give, this will force the caller to catch or specify it. Okay, this is part number 0, just this part. Okay, M2 is the caller of M3, and M2 is now being propagated about this exception. So now M2 is now, we said, subject to the catch or specify principle. So now M2 actually got 2 choices. Either M2 can choose to further propagate this exception here to its caller, which will be M1, or M2 can choose to catch it, which is to handle that. Now we got 2 options here. All right? Let's say M2 doesn't want to handle this exception right away. It doesn't want to take the responsibility. It simply propagates the responsibility to its caller, which is M1. So right here is basically part 1. I would say 1A. And 2 also specifies the exception. Okay, so 1A is the principle, another part of the principle. Okay, 1A. A caller may specify the exception. Okay, that's exactly just 1A. Okay, so we got 1A here, and also we got 1A here. So now this exception here is being propagated further to M1. Let's say M1 is the caller of M2. Again, it is subject to catch or specify. It can choose to further propagate the exception to its caller, which is main, which is fine. But let's say now we want to explore another possibility. M1 might choose to handle or catch the exception, in which case the exception catch or specify principle will end over there. It's not going to be impacting any further caller. So what do I mean? Okay, this one here is just a final possibility we're going to look at. So this one here will be 1B. Okay, I could put 1B here over here. A caller may catch or handle the exception. Once this exception here is handled once, it does not need to be handled anymore. Each exception only get to be handled by just once. Okay? Beyond this point, no further callers will be subject to the catch or specify requirements. No further callers subject to catch or specify requirements. Okay, let's see a little bit more visually. Okay, so for 1B here, M3 chooses to handle or catch the exception. So that's why when you see the arrow over here, it simply just go back to itself. It's not being propagated into the main method. It's not, right? Because it try to handle that. And when we say beyond this point, no further caller is going to be subject to, what do I mean by that? If you look at this one here, the main method over here is no longer subject to catch or specify requirements, because this method here already handles this exception here. So we should not expect this one here to either catch or specify. Okay? Let me recap. And then we take a short break, and I'll show you exactly how these can be translated into Eclipse. It might sound very abstract. I just want to go over the principle first, so you can look at that later. Let me recap, and then we'll do a short break. Whenever you want to talk about how an exception might be handled in Java or in any OOP, they do have like an exception mechanism in a very similar fashion. Think about you have some call chain. For example, main is calling M1, M1 is calling M2, M2 is calling M3. So we have a method call chain. And as soon as an exception occurs, the top of the stack usually, because the stack simply wouldn't grow any further if some error actually occurs. If an error occurs, that means the exception is going to be thrown. This is where the exception is being originated. Principle part 0. In this point here, we don't try to handle the exception right away. We will simply just specify the exception and propagate it to the caller. In this case, M3 has the caller M2. So M2 is now going to get this exception. And M2 is now going to be subject to catch or specify requirements. And let's say it chooses to further specify, which means it doesn't really take the responsibility. So that means the exception, this would be 1A. So the same exception is going to be propagated to M1. M1, again, is also going to be subject to catch or specify requirements. It does have the option to really propagate it further if it wants to, but let's say it does not choose to do it. Let's say it chooses to only catch it. Once it has caught the exception, now the loop is being closed. No further caller, including main method here, is going to be subject to this anymore. Okay? The catch or specify requirement, as we will see after the break, is going to be enforced by the Eclipse compiler. If you somehow violate the policy here, especially for 1A or 1B, you're actually going to get some compilation error. So that is something I'm going to show to you guys very soon. Okay? Why don't we take a short break by taking attendance? Well, as I said, the iClicker doesn't really work on my machine today. I'll try to fix it before Thursday, so today, no attendance check. Okay? All right, so now I want to move on to Eclipse right away, because before the break, we kind of spoke about this very abstract principle about the exception handling, basically about catch or specify. That's something I want to show to you how you can see that when working in Eclipse. Let's now see that. Okay, let me set out the context. So there's going to be different versions of code I'm going to develop together with you. Let's now take a look. Okay, let's now take a look at this. Right. So we're going to have basically 3 classes overall, 3 of them. We're going to get class A, we're going to get class B, and also class tester. A, B, and tester, 3 classes. So A has a method called MA, which takes some parameter, integer I. And somehow we want to say if I here is negative, then we have to signal some kind of error, which means we're going to throw some exception. I'm going to show you when I get to Eclipse. Otherwise, we do something else. And you can see that here, B here, and B, right? It's just another context. We are making this method call, right? You can see this is a method call over here. You can see right away, A.ma is the callee. And also B.mb is the caller. Right? You can see that right away. And we can see something very similar. Tester here is going to be the main method, right? Main method going to be the entry point of execution, that's for sure. And that one there, we also got another method call, ob.mb. You can see ob is declared as b. So here we have the callee will be b.mb, and the caller is going to be the tester, the main. And roughly speaking, if you try to trace this method call chain here, we're going to start with the method call tester.main. That will be the entry point of execution. And then we're going to go to this one here, which is going to be b.mb. And finally, we're going to go to a.ma. A.ma is where things might go wrong, where we're going to see how an exception can be originated from here, and from that point onwards, we're going to revisit the example, the principle that we spoke about. Okay? And in Java, starting from your lab number 2, you're going to also see how you can create your own exception. But it can be somehow generated by Eclipse anyway. So I wouldn't worry too much about it. But I'll show you how to do that. So let's say we want to create some exception. So every time you want to create your own exception kind in Java, you want to make sure your exception class, you can call it whatever name you like. Let's say negative value exception, okay, which is going to correspond to this condition here. And you want to extend exception. You don't need to worry about extend for now. It's actually something to do with inheritance, which we'll talk about in much greater detail after reading week, right? And then just a constructor for the exception. As I said, this one here can be automatically generated. You don't need to type anything. Okay, I'll show you. So you can fill out this table yourself about caller callee. Okay, I'll leave that to you. And we're going to see 3 different versions. So we want to see the following. When you actually got any exception here from here, now we got different possibility. When the exception got propagated to here, B dot and B got 2 choices. Either we can handle that right away here, or we can propagate it further to the main method. So there are 2 possibilities already. And then, let's say the exception got propagated to here, again, we got 2 possibilities. Either we can try to handle that over here, or it can be propagated to the console, which means the end user is going to see the exception, right? We're going to see some of the possibility together. So we got version 1, version 2, version 3, okay? We're going to see different versions. Okay, let's start with that first. All right, so I already got Eclipse here, and I created a project which I'll make available to you. Let's now try to create different classes, right? So I'm just going to create different packages just to separate. So let's say I call it version 0, just to set up all the classes. You know what, actually, let me call it version 1. I think we can start with that right away. Okay. Okay, let's start with version 1, and then we'll see how also the different syntax you can write in Java. Okay. So let me rename that into version number 1. Okay, and we're going to introduce 3 different classes. So we're going to get class A. Also, we're going to get class B, and also tester. Okay, class A here. And also we got class B. And finally we got tester. Okay, we're going to look at how to define them, each one of them. All right, we got 3 classes, A, B, and tester. Okay, let's start with class A. So this is going to be somehow eventually going to be called and generate the error, trigger the error. So let's say we got a method here. Let's call that MA. So public void MA. And then we got integer I. And let's say we somehow want to say, based on the input condition over here, we may or may not consider as an error. Let's say negative value means error. So we say if the I value here is less than 0, that means it's negative, we want to say there should be some kind of error. Otherwise, we are simply fine. No error, do something. Right, so that's a layout. So this is where the exception is going to be thrown. Let's learn the syntax. In order to throw an exception, you got to learn the keyword throw. And remember anonymous object that we learned earlier, right? In the review lecture, we can use anonymous object as well. So what you do is something like this. So you're going to say throw new. Okay? So throw here is the keyword you have to know how to write. Throw. It's more like a verb. And then anonymous object. I'm going to have a new exception object. Exception is simply just an object, like a class. And let's call that negative value exception. Negative value exception. And the constructor here usually will take some argument value here. You can just say a little bit more about the exception itself, right? You can say negative value, and then the actual value of I, right? You can just say, for example, if I give -2, you can say negative value of -2. It's not acceptable. Okay, like that. And of course, as soon as you say that, Eclipse is going to complain, this class does not really exist. So at this point, I would suggest you don't need to memorize anything about how to write out the contents for the exception. What you can do is, if you move your mouse over, one of the option there, the top option, create a class negative value exception. Eclipse can do this for you. Okay, just click on that option, the first option there. If you click on that, and then you can see that it's going to be created under version 1, just the same package, which is good. And then you can see that there's something called superclass. That one kind of corresponds to the extend keyword. Again, you don't need to worry about this one here. Okay, we're going to learn about superclass extends after the reading week. All you got to make sure is you type, just double check the name and also exception here, and then you can say finish. Okay. As soon as you say finish, there's only one thing you have to type, and this is something you can practice in the lab. Okay. Because we are having this constructor over here calling something with a string argument, right? You can see the constructor takes a string. So all you got to do is go back here and define that constructor. And then you can say string s. And then this line here, just type it verbatim, just for now. You'll learn about exactly what super really means later. But for now, just take it for granted. Okay, just for now. So up to this point here, things still don't compile, even after we have created this class over here. If you look at that, now we are having a slightly different error. Let's read it together. Okay. Now it is saying that on handle exception, this one here. So now we're going to follow principal parse 0. Okay. Let me remind you what principal parse 0 is about. Okay. If you go back here, where an exception is thrown, just specify it. You don't really try to catch it or try to handle that usually in the same place. Just a common practice. If you want to really choose between specify it or catch it, it will be up to the subsequent callers of this method here. All right, so I'll go back here. How do I specify an exception? So this another second part of the syntax you got to learn. In order for me to specify it, now you can see this is the end of the method. You can see the closing parenthesis, right? And this is the starting point of the implementation. You got to go between these two symbols. To specify it, you're going to use another keyword, throws. Guys, notice it's throws, not throw. Throw here is like a throw something, like an action. And this one is describing some behavior of the method so that any caller of MA will be aware that MA, the callee, may throw some exception. Okay, so that's like a specified. Okay, so now what kind of exception can we throw from there? Well, exactly this one. Just copy that. Now everything compiles. Let me recap what we have done so far. So we have got this class of A here, and we are going to signal an error if the input is negative. So we have created this exception class using Eclipse generation mechanism. You can feel free to use it. And we are throwing some anonymous objects of this particular kind of exception. And just by writing this, the code wouldn't compile unless you try to specify it. So this is the option usually you have to specify for the origin of the exception. Okay? That's something you want to keep in mind. Now, what we have done is, we have done with this part here. Any subsequent caller that will call MA, for example, MA is right here. There might be a method that calls MA. Then that method there is going to be subject to the catch or specify requirements. That's something I want to show to you. All right, let's see. Let's go back to Eclipse here. And let's now make MA a callee. And let's go to this class over here called B. I'm going to make class B a caller. public void MB integer I. All right, let's say just integer. And now, this is very important. In order for me to make b.mb a caller of a.ma, I need to first of all create some context object and call ma, right? So what I will do is I'm going to say, beg your pardon, mb here. So I'm going to create a object a, new a. OA, the context object, I'm going to call ma. And notice that ma here, I already specified ma throws some particular exception. As soon as you call this method here, the caller, which is b.mb, is now going to be subject to catch or specify requirements. This is where things will go a little bit tricky. Okay? So I'm going to say oa.ma. Whatever I that's passed to MB, I'm going to pass it verbatim to here. All right? Now, it does not compile. Because the catch or specify requirements is not being satisfied. In this MB here, at the moment, we neither specifies nor catches the exception. That's why it wouldn't compile. But if you look at compilation error message here, let's read it together. Similar. If you move your mouse over, it says, on handle exception type, negative value exception. So think about what's happening here. b.mb is the caller. It is calling the callee, which is ma. ma was specified to throw some error exception. Since it is specified to throw this exception here, now for mb here, you have option. Either you have to catch it or you have to specify it. Let's say we choose to specify it. All right? Sorry, let's say we choose to catch it. Let's see. I'll write some comment here for you. So this version will be good enough for today, but let's finish that. Okay? b.mb calls a.ma, which throws negative value exception. So b.mb is subject to the catch or specify requirements. At the moment, we haven't done specify or catch. Let's say we do the catch. Say b.mb chooses to handle or to catch the exception. So far we have learned about throws. We learned about throw. This will be the third part of syntax you got to learn about exception handling. Okay? The way to do it is you're going to do something called a try and catch block. So write try over here. There's going to be some, so you write a keyword try here, and then you will say catch. And for the catch, you're going to say which exception are you trying to catch. And for that one there, you're going to say, I want to catch negative value exception. That one, this block over here is more like a declaring a method. You got to give some name of this exception. So negative value exception. So this name here is kind of up to you. Right? I just use an acronym for negative value exception. So this is the try and catch block right here. Right? We might catch that. And then I'm simply going to make the method call itself into here. So this is the catch option here, not specified. Because you can see that here, we don't really have throws, negative value exception like before. We don't have it. We only have right here. All right? 1 minute, I want to do one more thing. If I go to tester, main method here. Right, guys, this is important, please. I might run overtime for 1 minute. Bear with me. So let's say I want to now make a caller here, main method. Now I'm going to call, let's say, b.mb. All right? So b, object b will be new, b over here. And now here's a question for you. Before, when I was trying to call OA.MA, I had a compilation error message, right? So I was kind of forced to either do catch or specify. But now, in the tester over here, if I try the following, OB.MB, no compilation error. Right here. No compilation error here. Why? Okay, I'll just link you to the principle there, okay, and then that'll be it for today. Just bear with me. So the reason that we don't really have any compilation error message is because related to this comment over here. Because here in that MB, we already catch that exception. So when we actually get to this caller over here, we don't really have to, it doesn't need to be subject to catch or specify requirements anymore. So this point here is related to it. All right, that's good for today. Before Thursday, review this page here again, and also look at the example code that we just developed, and then we'll go from there. Thank you.